Today, design of concrete structures. In the last session, we have introduced the reinforced concrete design. Today, we'll carry on and we will explain how we design the rectangular section. So this is a rectangular concrete section. This is concrete, and this one is the steel. So this bar is, or this bar represent the steel reinforcing inside the concrete. Now you see the first step is introduce the strain distribution along the depth of the section. So you see, we assume that the plane sections before bending still or keeps its straightness after bending. So you see here it is the ultimate strain in concrete is to be taken 0.0035. Sometimes in other codes they take 0.0035. So this concrete, which is hatched one, this one concrete in compression. So this one is concrete in compression. This one unhatched, it is the concrete in tension. And you see this concrete in tension, it is to be ignored. Why? Because concrete cannot resist tension. So this is the distribution of strain along the height of this section. Now you see here at the level of the steel reinforcing bar, we assume that the epsilon or the strain in steel exceeds the yield stress. So the design for this section is assumed that assumes that the steel yielded already. So now you see this is the distribution. Okay, based on this one and the stress strain diagram, we can plot this one. So this one is the stress. So this one is strain. This one is the stress distribution. Stress distribution within the compressive part of concrete, and you can see that this distribution is not linear. It is actually non-linear. So this is the stress distribution. So you can see that the maximum value for this nonlinear stress is F sub C prime, and alpha 1 F sub C prime is the effective compressive strength in concrete. And here in tension part, which belongs to, or which is acted on by the steel, I'll get AS F sub Y. So AS is this area of steel, and F sub Y is the yield stress of steel. If we go to this diagram, we see this one is the compressive. You see, you can compare that in this diagram. This one is the equivalent section. This one equivalent. Sometimes it is called Whitney. It is Whitney analysis, Whitney equivalent analysis. You see, in the last section, the compressive strength, the depth of compressive part of concrete is C. So you see C. But here we assume, or Whitney assumed, that instead of taking this nonlinear distribution with all of its complications, we can use an equivalent concrete block, which is rectangular like this, and it will be very much easier to deal with. And this equivalent just acts along a portion or just a percentage of the total depth C. That percentage is A. So A is less than C. So now we will analyze our section based on this approximation. Which is deemed to be almost equivalent to the original. So it will be based on this rectangle.